Let's do a countdown. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, liftoff. This is the Thursday meeting of the Warren Astronomical Society coming live to you from the home office. Thank you very much for joining us tonight. I see we've got a nice crowd here in the Discord channel, and I've seen that we have quite a few of you listening in on YouTube. So again, thank you for bearing with us during this unprecedented crisis. As is usual, I will be going through the officer and special interest group reports. We're going to treat this like a McComb meeting with the same format. However, there is going to be no time for a set snack break. You are welcome to partake of any food or drink that you like during the meeting because we can't see you. Okay, so President's report. Obviously, we are dealing with a crisis and we cannot meet in person. And we are working with that. I'd like to give a shout out to Doug Bach for the Northern Cross Observatory for lending us use of his Discord server so that we could make these virtual meetings possible. Otherwise, we are dealing with the same crisis through all the other astronomical communities, GLAC, Ford Club, etc. So we'll touch on that in some of the other reports, but otherwise, for the foreseeable future, if you could stay in touch with us through Meetup, Facebook, or our MailChimp mailing list, we will do our best to keep you abreast of what's going on and let you know about opportunities to do live events like this with us. As far as our first vice president goes, we've had a switch in plans for tonight. We're going to be going with Jonathan Kade's Satellites of Love instead of Bob Trembley's presentation. For the next meeting that would have been on at Cranbrook, we're going to be doing a special observing event. The original plan was going to be to observe in person at Cranbrook. Since we cannot be there, we're going to be using this format of live streaming to do a special observing event in conjunction with the Northern Cross Observatory. So look forward to that, and let's keep our fingers crossed that there will be clear skies. But since it is live streamed, we can be flexible about the weather. Coming up in April, McComb meeting, in other words, a Thursday meeting like this, Jerry Dunifer will be presenting cosmic fireworks. So we're looking forward to that. If you are interested in giving a long presentation or a short presentation, if you could give First VP at warrenester.org a shout and sign yourself up. Second VP, Observatory Chair Riyadh's with us in the chat room, but we will not be meeting at Stargate. That means that our open house is not going to be happening this month. We will be doing, again, a virtual streaming event. So look forward to that. We're going to be trying to get astronomy into your house as much as possible. Secretary report, Glenn has been doing a great job with the minutes. You can read the previous months in the WASP, and he'll be ready to go with the Observatory. Riyadh's in the chat room, but we will not be meeting at Stargate. Back in business. So we've got the secretary reports are in the WASP. We've got the treasurer reports in the WASP. We are still taking renewals for both membership dues and the Astronomical League. You can pay online, so please check out our website and sign up again. As far as our outreach goes, this is the shortest outreach report ever. Everything is canceled for the foreseeable future. Please stay in touch with us to see when we can start doing actual outreach events. We are still in communication with the upcoming Discovery Center from Mount Clemens. However, they will not be opening on time as a result of the crisis. Publications welcomes any contributions as far as reviews, as far as solo observing, think pieces, any sort of articles, please submit them to publications at warrenastro.org. Okay, we got a little technical difficulty here. Going to try to carry on with the special interest group reports before we switch gears for in the news. Special interest group reports. Discussion group is canceled. Hands-on is canceled. Astrophotography. Anyone interested in learning about astrophotography or any questions regarding equipment, how to take astrophotos using our iPhones, or any related questions, please contact our Captain Bill at beezoll@aol.com. This will be included in the WASP going forward. As far as solar goes, there was an unconfirmed report of a small sunspot yesterday. However, given it is currently raining, we can't see it. And as far as interclub activities go, the Ford swap meet that was going to be the 21st of March at Henry Ford College has, of course, also been canceled. So I believe that is it for the subgroups. Bob Tremblay is posting a nice photograph from the Solar Observatory in the Discord channel if you want to see what the sun currently looks like. There is not a lot to see at present. I did have a humorous report from our solar subgroup, Captain Marty, who says he has purchased a new solar scope of his own, or rather a used solar scope, and you can blame him for any rain in the immediate future. Okay. We are going to do our virtual In the News in the Sky presentation, so bear with us while we switch gears for a minute, and we will be back shortly. All right, can everybody see In the News, March 19th? So, top story tonight, Al Worden, the Apollo 15 command module pilot and a native of Jackson, Michigan, died in his sleep at the age of 88 on March 18th. Worden orbited the moon as the command module pilot. The mission was a scientific success and a PR disaster for NASA. This was the first of the extended scientific J missions that deployed the lunar rover that you can see down there in the bottom corner, and it brought back the famous Genesis rock, shown at the top. In fact, it brought back a whole haul of rocks, many of which have not yet been touched by scientists to this day. While his crewmates David Scott and Jim Irwin were driving the rover and collecting the rocks, Worden orbited the moon alone in Command Module Endeavour for 3 days, setting a new record for the most isolated human alive. While the mission was fabulously successful from a scientific perspective, the crew was unfortunately disgraced upon returning to Earth. It became known that they'd accepted payment to the tune of about $7,000 apiece from a West German stamp dealer to carry commemorative stamp covers to the moon. This was a scandal at the time, and the 3 of them were actually called before a closed session of the Senate to be reprimanded. None of them were ever allowed to fly again. Worden did also bring, less problematically, a letter from Mr. Rogers of Mr. Rogers' Neighborhood that he then joined Fred Rogers on his television show to read it aloud and talk about his experiences, thus becoming familiar to many children, including me. I was not alive in 1971, but I saw it on repeats, as Al the astronaut, friend of Mr. Rogers. So rest in peace, Al Worden, a great Michigander. Got some good news from Mars. Our InSight's digging probe, known as the Mole, has been stuck for a year. It appears to have been freed after a last-ditch effort to get it out. The risky maneuver, which potentially could have severed power and communication cables, was practiced for months before being executed. The InSight team honed its quote-unquote gardening skills and freed the probe by effectively telling InSight to hit itself with a shovel. The probe was directed to land its own robotic arm down on the mole. Video from NASA, of which a still is shown above, indicate that this worked. NASA hopes the mole can get back to digging to analyze subsurface Martian temperature fluctuations. Another happy news. We've got a name for the Mars 2020 rover. Perseverance will be joining InSight and its sister rover Curiosity. Perseverance is set to launch in the upcoming July-August launch window this summer, and hopefully will touch down on February 21st of next year to look for life on Mars. And last positive news. The ESA Roscosmos collaboration ExoMars, also a lander/rover searching for signs of life, will be delayed until 2022. The astrobiology program was supposed to launch during the same summer launch window for Mars, but recent attempts to fix issues with both electronic angle and the software components with the lander and the rover have been disrupted by the COVID-19 outbreak. When the Rosalind Franklin rover does land, hopefully in 2023, it, like Perseverance, will search for signs of life. Meanwhile, COVID-19 is wreaking havoc on star parties and astronomical events, as we are experiencing. The famed Northeast Astronomy Forum and Telescope Show is moving its April 4 events to a virtual expo and is rescheduling its physical events to September 12th and 13th. The facility there, Rockland Community College, is, I believe, near a hotbed of coronavirus activity right now, so this was expected. It is, of course, only the tip of the iceberg as far as astronomical cancellations go. However, as we weather this period of social distancing and self-quarantine, the second man on the moon has quarantine advice for us all. Of course, Buzz Aldrin and his Apollo 11 crewmates spent 3 long weeks in isolation in a converted Airstream trailer after returning to Earth from the moon. Buzz has reminisced recently about the conditions in their quarantine, remembering that he and Mike Collins kept in shape by jogging in the hallway. The famously exercise averse Neil Armstrong did not join them. Buzz noted that the trailer was far from airtight. In fact, they could see a stream of ants coming in and out of a crack on the floor. If your quarantine has ants coming in and out, you might want to fix that. Buzz says that he is weathering the current crisis by lying down and locking his door. So, wise words from a man who knows how to deal with isolation. That's in the news. What have we got in the sky? We've got quite a few things. Just a taste. Spring has sprung, or rather will be springing tonight at 11:49 p.m. Eastern Daylight Time will be the official beginning of spring. This is the earliest that we have had an official spring in 124 years, thanks to some complicated math involving leap years, leap centuries, the Gregorian calendar, and the actual solar day. For 2021, the equinox will revert to the more usual March 20th. News, Betelgeuse, that we have been fretting about through the winter as it dimmed to magnitude 1.64, in other words, pretty faint by its standards. It is up as of March 18th to 1.1. The change from the minimum is obvious to the eye. I would love to verify that myself, but it's cloudy. In any event, cancel the Death Watch / supernova party for Betelgeuse. It's back. If you have clear skies, you will have a very nice planetary show in the morning. On the 20th, Mars and Jupiter will be a mere 0.7 degrees apart, and Saturn will be hanging out nearby. The moon will be joining them, and it will be very pretty. If you have clouds, we feel you. Finally, we have optimistic news involving a comet. Comet Atlas, otherwise known as C2019Y4, a hyperbolic comet, is currently in close proximity to the orbit of Mars and is headed for the sun. Right now, it is about 8th or 9th magnitude, well within reach of amateur scopes. Of course, far too dim to be visible to the naked eye, but it is predicted that in the latter half of May, when it is about 0.25 astronomical units out, its amplified glow will be somewhere between a waxing crescent moon and a first magnitude star. That is really something to look forward to. That would be the first really good Northern Hemisphere comet we have had since Comet Holmes
in 2008. So we are overdue for some cometary action, and Comet Atlas might deliver. Atlas has also been found to be hundreds of times larger than previously estimated. So let's hope he puts in a show. Here is an amateur photograph out of Italy showing a beautiful green comet up there, hanging out with the famous pair of M81 and M82. So quite a stunning composition. And that is in the news in the sky for this week. I will turn this monitor back over to Jonathan so we can do our observing reports.
We can now take any observing reports from our members. If you're in the Discord or if you are in the YouTube, I'm looking at the comments there. So if anybody would like to add any observing reports, I know that Doug, of course, has been doing a lot from the Northern Cross. Yes, you want to tell us about T2?
Yeah, I've been following Comet 2017 T2 since October, and it's actually getting brighter as well. It's about 8.5 magnitude now, and I've got at least about 8 or 10 images over the last 6 weeks of it moving through the northern part of the sky as well, and it's very much should be visible through moderate telescopes as well. So that's another opportunity right now.
Doug, do you want to pull up any of those photos to show on the YouTube channel?
Yeah, I can show those on the YouTube channel. I tell you what, let me just pull up the one mosaic. Well, here's Comet Atlas right now. The YouTubers will see this. Let me go live here so you can see it. I remember how to do this. There we go. So this is Comet Atlas as of 2 nights ago on the 17th. It's moving quite quickly. This is a stack of 20 images. They are each 1 minute apiece. So that's about 20-25 minutes worth of movement on those star trails. And then show you the latest of T2. There we go. Here's T2. This is just 6 images of T2 1 minute exposures. It's pretty bright as well, as you can see there. Well, that's my comet report for this time. Okay.
Very cool.
Very cool.
And
thanks, Doug.
We have a question on the YouTube channel from Diane Rosado. Do we think Betelgeuse is going to explode soon?
We do not. We do not. It's I believe the last set of analyses was that the dimming was caused by dust, or seemed to be caused by dust. But the fact that it's brightening up again suggests its death is not in fact imminent, which is fine. It's a nice star. We also have from CNG News, they have done a story on us. And it's called As Spring Equinox Nears, Look to the Stars by Mary Beth Almond. And we've got the link posted in the Discord. And it's a very nice 2-page spread with colored pictures featuring photographs from Bob Berta, who unfortunately was not attributed, even though it's very definitely his work, and Bill Beers. And it talks about many of the local astronomy clubs, including us. So very, very cool. Nice thing to get in the news, especially given everything else going on. Any other observing reports or questions? We're a bit ahead of schedule, so we do have some time.
The third quarter moon was really beautiful on the way to pack my house down early in the morning.
Nice.
It would have been great for schools if there were any kids at schools.
We do have another astronomy question on the YouTube chat. What
Let's
makes
hear.
a comet green?
Oh, that's a good one. Anybody want to field that?
I'm using the interwebs.
Yeah. I mean, one thing is basically cyanogens. So comets are green because they're actually, the chemical composition does make it green.
So I've seen that I've seen people call it oxygen. Like I've seen people say that oxygen is the reason. So what exactly is cyanogen?
Okay, so in the case of a comet, so it's the color of a planetary nebula, the green glow is oxygen 3. In a comet, comets contain carbon bonds. So carbon nitrogen bonds, which, since carbon's chemical symbol is, or atomic symbol is C, and nitrogen is N, that's represented by a CN, and carbon carbon bonds, which are C to C. Organic chemistry, bear with me. The light of the sun will actually excite the electrons in these bonded molecules. And as the excited electrons drop back down from one shell to another inside the atomic structure, they emit a green glow. So, very, very cool, fun piece of organic chemistry.
I'm sorry, you at least for me, you cut out for part of the culmination of that
Nuts.
explanation. But
Yeah, basically the electrons in the organic molecule bonds are excited, and when they drop back down to their normal place in the atomic structure, they emit color.
okay, so we have one. I think we have time for one more question on the Discord channel. So about the Doppler effect and about redshift and blue shift from Catherine. So when we use spectroscopy to determine the chemical composition of distant objects, but they're being redshifted or blue shifted, how can we compensate for the redshift and blue shift? Like how do we figure out, how do we tell the difference between the chemical composition and the redshift and blue shift? Because we're looking at the same spectra for the same chemicals either way, and how do we not mistake, the one for the other?
So the shift is going to shift the entire spectrum. So you're going to get signatures of whatever chemical element you're looking for, and the shift is going to be the same across the entire spectrum. So whatever shift you're going to see, there's a easy formula for converting that shift that you're seeing to how far away or how fast the object is moving relative to you, depending on what you're measuring. Not sure if that answers the entire question.
I think it answers about half of it. And the thing that I would add to that is that so chemical spectra are like fingerprints. So the same chemical is always going to have the same chemical spectrum. And there's actually two different fingerprints. One of them is the absorption spectra. So when there's a cloud of hydrogen dust, it's going to absorb certain wavelengths of light. But then when you light that hydrogen on fire, it's going to emit certain wavelengths of light. And so the absorption and emission spectra are different, but are they the same lines? Does anyone know?
Yes, they are.
Okay, so it's the same positions, but one of them is glowing where everything is dark, and the other one is dark where everything else is glowing.
Yeah, bright line and dark line spectra.
Correct.
So when you see those fingerprints, and we have a bunch of really useful tools for sort of disentangling the different spectral lines and figuring out what chemicals are actually glowing or what chemicals are actually there in a gas cloud that's absorbing light either way. And so then those fingerprints, like there'll be one line down at the bottom, two lines in the middle, and then one line up high. And when you look at those four lines, as they shift up, they're being shifted towards the blue. They're moving away from us. If they shift down, they're being shifted towards the red. But all of the lines move equally together for that particular chemical, and all other chemicals as well. So
Flip the direction. Blue is towards us.
well,
Red is away.
well, I was looking in a mirror.
All right. Well, that's excellent. It's 8 o'clock. We are again a bit ahead of schedule, but if there's no additional questions, we can proceed with the featured presentation of the night. Thumbs up, Jonathan?
Yes, I'm ready to go. Just let me give me a second until I go live. And
Okay. Well,
if somebody wants to introduce me,
I can do that while we're giving you a second. So tonight's presenter at short notice is Jonathan Kade. Jonathan is our current publications chair. He is a past president, past treasurer, past secretary, and past first vice president of the club. So he's done just about everything. He's also my favorite observing partner, who is the person manning the scope while I hold the laser pointer. So Jonathan's interests include manned spaceflight, urban observing, historical observatories, and the planet Venus. So Jonathan, take it away.
all right. So if you're in the Discord, you're going to want to click on my name and then click join the stream. If you're on YouTube, you can just sit back and try not to fall asleep. So a few years ago, we had a transit of Venus, and a transit of Venus is when the planet Venus passes between the Earth and the Sun. There have been two in my lifetime, 2004 and 2012, and those are the only ones in my entire lifetime. The next one is, I believe, going to be 2122 or something like that. So I did a presentation about transits of Venus. I did one leading up to the transit of 2012. I did one after the transit of 2012. And then Diane said that I needed to find something new to present about. And I decided to keep on the Venus subject. And so I present here the second recent iteration of Satellites of Love, Missions to Venus. I've actually given this twice before, but the early edition was very old and very short. So I hope too many people haven't seen it before, but I have added some new stuff, and some things have recently changed. So you may recognize this photo of Venus as not invisible light, because normally all we see is a bunch of... Ken Burton informs me that it's the year 2117, so I will probably not be here. If I am, something has gone terribly wrong with human civilization. So why do I care about Venus? Well, Venus tells us a lot about our home planet. Even as far back as Galileo, the letters on sunspots used Venus's phases and changes in size to disprove the Ptolemaic universe, to show that the sun was actually at the center of the solar system and not the Earth. And that got Galileo in some degree of trouble, but that's neither here nor there. It allowed us, so those transits that I was talking about, allowed us to figure out how far things were from each other within the solar system, which is the first time we really got a sense of the scale of the universe outside our everyday lives. It helps us understand exoplanets. So doing spectroscopy on the atmosphere of Venus has helped us practice analyzing other planets' atmospheres from afar, to do spectroscopy to figure out what chemicals are in those atmospheres. And even, watching transits of Venus in front of the sun gives us really great calibration tools for understanding how those exoplanets passing in front of far away and unfamiliar stars actually behave. So it gives us a great way of calibrating with chemical compositions we do understand to help us better detect the chemical compositions that we don't understand. And finally, it looks a lot like Earth. And it might tell us something about our own future, or at least one of our possible futures. A future that I think we would prefer not to have. I'm going to pull up the YouTube channel here on my phone so that I can see comments from YouTube as well. So, you typically hear that Venus is one of our sister planets. It is our sister planet. So this gives you some idea of the scale. These are to scale. So the Venus photo is actually a radar map from Magellan. The Earth photo is taken from the Apollo 17 moon mission, the final mission to the moon by humans so far. So Venus has a lot in common with Earth. The radius is 95% of Earth's. The surface area is 90% of Earth's. The spatial volume is 87% of Earth's. The mass is 82% of Earth's. The surface gravity actually works out to be 90% of Earth gravity. So there's one big difference. You probably know what it is. The surface temperature on Venus is 864 degrees Fahrenheit. Not a good place to practice social distancing. It's more a place to practice social obliteration. So looking at the numbers for its atmospheric composition tells you a lot about what's going on over there. It's 97% carbon dioxide, 3.5% nitrogen, and then a bunch of very small trace amounts of chemicals. When you compare that to Earth, it's really obvious how big of a difference there is. Earth is 78% nitrogen, 21% oxygen, almost 1% argon, and only 0.4% carbon dioxide. So we definitely don't want to be joining our sister in that regard. So that's sort of one set of reasons to be interested in Venus. But while we, gosh, I don't know how I don't know how I'm going to do this. Maybe somebody can unmute and tell me if there are any guesses in the channel. But I'm soliciting your opinion. How many missions have humans sent to the planet Venus? Somebody's going to have to unmute and tell me.
We have one guess for 5, and we have one guess for 60.
22. We have quite a spread so far. All right. Well, I've got the answer
Jonathan,
for you.
What do you consider a mission? Are you counting orbiters and landers?
And even flybys that actually have significant mission objectives on Venus instead of just using it for its gravity.
Thank you.
All right. Are we ready? This is the sum total of Venus missions so far. There have been 43 as of the present day. I hope I counted those right. Looks like it. Now, only 27 of those are successful. A lot of the early ones, as you might imagine, didn't go so well. But one of the reasons I think you don't hear so much about exploring Venus is that many of those missions, including some of the most scientifically successful ones, were actually sent by the Soviet Union. And that's definitely the competitive relationship and adversarial relationship we had with them, I think tended to make people not talk about the successes that we as a species have had in exploring there. So we'll get into some of the details. So does anyone have any ideas about when we first tried to get to Venus? And again, I'm going to need somebody to unmute. Have any guesses?
Jeff thinks 1964.
I didn't hear Doug's actual guess. Mid to late 50s. Okay, so we had 64, mid to late 50s. So it's actually right in between. So Tchezhely Sputnik was 1961. It was the first attempt by the Soviet Union to get there. And the US was close behind. So Tchezhely Sputnik was 1961. It was actually the second Sputnik mission, I think, or maybe the third. The Venera 1 was the first spacecraft ever sent by humankind to fly by another planet. But unfortunately, it died just after it left the Earth's atmosphere, and so it was just a hunk of metal floating by Venus. But nevertheless, it was a first. The Mariner 1 probe actually did pretty well. And the 2MV1 probe, which is another Soviet probe, actually had a lander on it. So they hadn't even gotten there yet, and they're already trying to send landers. So there was a division of the Soviet space program. Basically, the Soviet space program at this point consisted of one man's bureau, and they had serious problems building stuff that worked. One of the reasons, we'll get into that in a second. So Mariner 2 was the first successful interplanetary spacecraft. It launched on August 27th, 1962. It passed 21,000 miles away from Venus. It recorded the temperature at Venus for the first time, revealing that the planet had a very hot atmosphere of about 500 degrees Celsius, 900 degrees Fahrenheit. So that was basically right, and we've just been refining those temperature ranges ever since. So that was the early success, that and Venera 1. But there were a lot more failures to come. So the Russians kept getting closer and they kept trying really hard. Despite the lack of a successful flyby, they started sending landers in earnest. So the 2MV series and 3MV series all had landers. Zond 1, which is pictured here, and Venera 2 flew by the planet, but they died before they sent their data back. Venera 3 actually succeeded in landing a lander on the planet, but it died on entry to the atmosphere and crash landed. And so here's the thing. The bureau that was doing most of the Soviet spaceflight building was really overwhelmed. So this man, Sergei Korolev, he was the father of productive Russian spaceflight, but he was in charge of the crewed spaceflight program, the autonomous probe spaceflight program. He was trying to get people to the moon. He was trying to do stuff in orbit. He was working with the military, and it was just very difficult for him to get traction on all these projects that he had with the people that he had. So a bunch of stuff got taken away from him, he was told that he was to concentrate on landing a man on the moon, and that was what his job was. And an aircraft engineering firm, NPO Lavochkin, which was headed by his friend Gregory Babakin, actually took over the Venus probe program. And they started changing the engineering practices. So Sergei Korolev was a really amazing guy. He had a lot of wonderful qualities that made people really love him who worked with him. But he had what I consider to be a very fatal flaw in somebody building extremely complex systems with lots of explosives on them, which is his approach to testing was based on the approach to testing used by people who were just trying to shoot missiles at other armies, ballistic testing procedures. He didn't do any unit testing. He didn't test any individual components on their own. And so these probes would almost work, but then they wouldn't be designed for certain gravitational, a certain G-force. And so they would die when they hit that G-force. And so it just ended up wasting a lot of effort and a lot of money. And 99% was fine, but it was that 1% that killed it. And so when the Lavochkin Bureau took over, they began a comprehensive testing program of the Venus probes and the Luna moon probes. And they discovered that the Venera landers that were trying to land on Venus, they actually would die at half of the gravitational force that they experienced on entry. So obviously they were never going to make it like that. So when they took over Venera 4, they actually successfully got it to land. It proved that there was no water on the surface. It took temperature and pressure readings as it parachuted down. And it actually did chemical analysis on the atmosphere on its way down. So finally, finally the Soviet Union had gotten a successful landing. So meanwhile, in the US, Mariner 5 was actually a backup for the Mariner 4 Mars probe. And since Mariner 4 was a success, they didn't need to send the backup, and they decided to repurpose it for Venus. So the spacecraft just did a flyby, but it provided detailed information about the planet's atmospheric pressure, 75 to 100 Earth atmospheres, and it got a more precise temperature reading, 527 degrees Celsius. It found no trapped radiation belts around Venus like the Earth's Van Allen belts, and Venus's magnetic field turned out to be only 1% as strong as Earth's. So despite Venus's similarity to Earth in terms of size, the spacecraft Mariner 5 is what really showed us that it was a completely different world from what we're used to. So the Soviets just kept going. Venera 5 parachuted down, and it actually had a photo sensor. It didn't have a true camera, but it took visual density readings of Venus's atmosphere. So Venera 5 worked. The photometer on Venera 6 did not work. Those two probes confirmed the Venera 4 pressure and density readings, did more chemical analysis on the atmosphere, and these two probes actually survived for a surprisingly long time. Venera 5 survived for 53 minutes on the surface. Venera 6 survived for 51 minutes on the surface. The spacecraft each carried a medallion bearing the state coat of arms of the USSR and a relief of Vladimir Lenin, both of which melted down. So that always strikes me as funny. Those ones survived on the descent, but they died on the surface. So the first one to actually survive on the surface was Venera 7. It landed, it rolled over, and ended up on its side, so the antenna wasn't pointing back at Earth the way it was supposed to. So at first they thought that the probe had been a complete failure, but when they looked at the magnetic tapes, when they looked at the signals on the magnetic tapes closely, they realized that they were just an order of magnitude fainter than they expected them to be. So the main data that it took, the surface temperature was 887 degrees Fahrenheit. So the first totally successful landing was Venera 8. It had a photometer, and it actually started, it was the first probe to actually figure out what the different layers of the Venus atmosphere were like. It measured that in the band between 35 and 30 kilometers altitude, the clouds were super thick compared to above or below that. And wind speeds under 10 kilometers were very low, less than a kilometer a second. So Venera 8 landed at 9:32 Universal Time in what's now called the Celia region, in sunlight about 500 kilometers from the morning terminator. So this is a 500 kilogram probe. It's a huge probe. And from the surface, it continued to send back data for 50 minutes and 11 seconds until it finally started melting down. And it found out the most important thing for the purposes of this presentation is that it actually measured the light level on the surface and said, yes, we should send a camera here. If we send a camera here, we can see stuff on the surface. It's not, because at that point they didn't know what the atmosphere is like down at the surface. Was it foggy? Could you even see any distance at all? Was there any point in sending a real camera to the surface with all of the stuff you'd have to do to make that work? So it also had a gamma ray spectrometer on board, and it measured the uranium, thorium, potassium ratio of the surface rock. And it basically discovered that the bedrock of Venus is similar to Earth granite. So that was successful, and then they had a lot of problems. The Cosmos 167, 359, and 482 were all failures. So you might have noticed that the ones that are called Venera all succeeded in one way or another. The ones that are not called Venera all really failed. The reason for that is they only named them. It's that George Orwell thing. They only named them as if they were going to Venus if they got there. If they failed, well, they weren't going to Venus at all. It was a different kind of test. So it was just trying to save face. Well, we didn't quite do that. So Mariner 10 was not intentionally a Venus probe, but it was on its way to Mercury for the first close pass by Mercury ever, but it used Venus's gravity to do a flyby, and it brought on board a great camera, and it took the earliest iconic photograph of Venus up close. So this photo is from 1973, and it's still used, it's still used in textbooks in my childhood. So Venera 9 and 10, 1975, 2 years later, land and take the first ever surface photos. So these photos were, these are the photos that were historically released to the press by the Soviet Union. It says, you might be able, if you read Cyrillic, it says Venera Obrabotka ili on, from the Soviet Union, SSSR. So these are pretty cool photos, but they're very blurry. Well, there was a man who has a wonderful website called mentallandscape.com named Don P. Mitchell. And Don P. Mitchell, because he was super interested in the Soviet space program, got in touch with some people who had access to the original data who made it available to him. And so he got these original source data. And you might see that they have some serious image artifacts in them. But he found out what he realized in looking at the actual binary data was that you could actually correct for those. And so he was able to reconstruct that data that had gotten messed up and come up with much nicer photos. So these are the Venera 9 photos that he reconstructed. So this shows the reconstruction process. The top one is the corrupted data, the middle one is during reconstruction, and the bottom one is the final one. Likewise with Venera 10, the corrupted one, the in-progress reconstruction, and then the final reconstruction. And I think it looks kind of similar to Mars, but we'll see a little bit more shortly. I just think it's really awesome to actually see the surface of Venus, because that's not something that, when I first found these photos on the internet, I basically immediately said, I'm doing a presentation about this because I didn't know there were surface photos from Venus. So, the US had not given up on Venus yet. The Pioneer Venus orbiter arrived a few years later, 1978. And so there were two components of the Pioneer Venus program. So Pioneer 12 was the Venus orbiter, and it took radar maps of the surface from orbit. And this was really cool. And you'll hear something amazing about this. So remember, this is 1978. And the second part was a set of landers. Now, the US hadn't really been interested in landers before. And so this was their first attempt at actually doing a lander. So this gives you some idea, and you might look at this really interesting sci-fi looking photo and wonder, what are all of those different pieces? Well, it turns out, I don't know if you can see my mouse cursor, but, well, maybe I can do this. So this is, and so this carried one large probes. The idea is that they would drop the probes at different places. So they would land one on the northern part of the terminator, and light, one on the southern terminator, one on the night side, one on the day side, and then the whole big bus would come in after all of the other ones. So the bus would relay back signals from the landers and then go in itself and do chemical analysis on its way down. And so the bus itself did ion mass and neutral mass spectroscopy. So on December 9th, 1978, each probe took 45 minutes to land. The dayside probe survived on the surface for over an hour after it landed. Below 50 kilometers, the temperatures measured by all four of the landing probes were identical to within a few degrees. 838 degrees Fahrenheit to 858 degrees Fahrenheit. The ground pressure was between 86 bars and 95 bars. They, like the Russians before them, discovered that there were 3 separate cloud layers. And they found out that the ratio of 36 argon to 40 argon, different isotopes of the rare gas, the noble gas argon, was much higher in the atmosphere than on Earth. So because noble gases don't react with anything, that tells us that the chemical composition of Venus's atmosphere was originally much, much different than Earth's. So even though there are certain similarities, at least we have the consolation of knowing that the way that Venus started was already way different than the way that Earth started. So maybe this is not a future we have to worry about so much. So, the probes were able to figure out the wind speed at the 3 different cloud layers. So at the top cloud layer, at the middle cloud layer, the speed was 200 meters per second, the wind speed. At the base of those clouds, at the bottom of that cloud band, it was 50 meters per second, and at the ground, it was just 1 meter per second. So it's Venus is a planet with very, very strange wind systems as well. So Venera 11 and 12 were attempts to land and take color photographs of the Venusian surface. Unfortunately, both of them had spring-loaded lens caps, and both of them got crushed by the atmospheric pressure on entry, and the caps couldn't eject, and so they were not able to take photos. They did collect some important data, including recording gamma ray bursts on the descent. They recorded thunder and lightning in the atmosphere, which was actually controversial. Like, nobody in the West believed it for decades. And they found measurable quantities of carbon monoxide near the surface, which is pretty interesting from a chemical evolution standpoint as well. So what they really wanted to do out of these probes was get color photos. They didn't work out for that. But thankfully, along came Venera 13 and 14. So same year I was born, we actually succeeded as a species at getting color, high-resolution photos of Venus as well as color photos of Venus. So again, these photos that I'm going to show were reconstructed from the original data by Don P. Mitchell of mentallandscape.com. So these give you much better ideas of what it's like to be on Venus. And one thing that you immediately notice is that this is a very flat world. So where Mars looks a lot like New Mexico or maybe parts of Colorado, Venus is like Michigan except without the plants. Just very flat in many directions and just little hills here and there. So here are reconstructed color photos. So this is the true to life color that was recorded, also reconstructed by Don Mitchell. And you can see the lens caps still lying there on the ground where they shot off. And from Venera 14. And so there's the color strip that allowed them to calibrate the colors for a true visual representation of the color there. So Venera 15 and 16 were not landers. They were intended to operate together to do a radar survey of the surface, just like that Pioneer Venus orbiter was still going here in 1983. So for 5 years, the U.S. had been mapping the planet, but it was significantly lower resolution. So the Soviets wanted to map at high resolution, and so the two were inserted into orbit a day apart, shifted by an angle of 4 degrees, and that made it possible to re-image an area if they needed to. So this is Don Mitchell's reconstruction of the high-resolution mapping that they took from orbit. Each of them was in a polar orbit with a periapsis at 62 degrees north, and this represents the area from the North Pole of Venus down to about 30 degrees north latitude over 8 months of operations. So they were only able to image about 25% of the surface of the planet. The Pioneer Venus probe mapped about 85% of the surface of the planet, but at much lower resolution. So we're getting towards the end of the Soviet space program for reasons you may be aware of. So the Vega probe is actually a 2-part probe. Vega is short for Venera Halley, and so it's Veja. So Halley as in Halley's Comet. So it actually was a 3-part probe. There was a flyby craft that dropped off the other parts, and then went on to rendezvous with Halley's Comet up close. There was a lander, and then there was a balloon set. So the landers were supposed to take seismographic data, but unfortunately, Vega 1 got the seismograph triggered in midair, causing it to basically take all of its seismological data while it was still floating on a parachute, which wasn't really scientifically valid. So the only real science that did was the mass spectroscopy or mass spectrometer on the surface rocks. But the third part of it was really cool, and they were the first balloons on another world. So the Vega 1 and 2 weather balloons basically were inserted into atmosphere. And actually, this is Jeff Landis. He is he used to he may still work for NASA. He works at the John Glenn Research Center in Ohio that is doing a lot of Venus research. So he's so into Venus stuff that in his spare time he takes pictures of this stuff and uploads it to Wikipedia. So you can rest assured that the NASA Venus scientists are very into Venus too. But these probes were inserted into Venus's atmosphere, and they actually drifted for over the course of about a day and a half. They drifted across 30% of the circumference of the planet. So each of them covered about a third of the circumference of the planet, and took a lot of wind speed readings, and so I think this is just super cool that we had balloons floating in the atmosphere of Venus. The upper atmospheres, the upper cloud layers, are really good places to be on Venus compared to some of your other options. So I'd like to see us do more of this in the future. So now we're getting more into my lifetime. Magellan, 1989, took the first detailed map. And so it arrived at Venus in 1989. For the first 3 years, when it was at Venus, it was working in tandem with the still living Pioneer Venus orbiter, which, if you'll remember, got there in 1978. So that orbiter actually lasted until 1992. So for 13 years, or for 14 years, that orbiter was taking data around Venus. So even though the U.S. wasn't sending, even though the U.S. was not sending very much, very many spacecraft there, they were able to send a lot of probes, or they were able to take a lot of data despite not sending very many probes. So the pictures you've seen of the surface of Venus, of what the geological surface looks like, pretty much all derived from Magellan data. And Magellan's radar mapping was super high resolution, and it really gave us an idea of Venus as we know it today. This beautiful false color map that tells you sort of where the different chemical deposits are. We actually have a globe of this sitting in our living room at home. And because it took topographical maps, we can actually do detailed 3D simulations of what Venus looks like. Okay, so now we're in the gravity assist flyby, aka chopped liver years. So Galileo flies by Venus, just uses it to get to Jupiter. Cassini flies by Venus twice, just uses it to get to Saturn. Messenger, what a wonderful probe, but it just uses it to fly by and get to its visits to Mercury. And so these were pretty disappointing years for fans of Venus, because we literally are visiting there every few years, and we're literally taking no data whatsoever. And it's just a very, it feels very unfair to the planet as well as to its aficionados here on Earth. So So this is the only data that the MESSENGER probe took of Venus. It simply took a series of photos as it receded away in space. But thankfully, some other people were interested in Venus, and the European Space Agency sent Venus Express there in 2006. And that reignited the era of Venus space science. So it was intended to do high-resolution observation of the Venusian atmosphere over long periods of time. It confirmed the Venera observations that there is lightning and thunder on Venus's surface. It discovered, in fact, that lightning and thunder is more common on Venus than it is on Earth. It discovered that Venus has an ozone layer of its own, a potential region where dry ice might form in the upper atmosphere, a stable double polar vortex at the South Pole, and it collected evidence that Venus once had oceans. So it was a long-lived probe. It got there in 2006. It finished its mission in December 2014, and it was plunged into Venus's atmosphere in 2015. The only current mission to Venus is the Japanese Akatsuki probe, which got there in 2015. Now, the Japanese space program has accomplished amazing things, but they've often done so in really hair-raising, skin-of-your-teeth ways. You may be familiar with the Hayabusa probe that had about 6 different calamities occur before it collected dust from a comet and succeeded at bringing back 3 or 4 grains of it back to Earth. Akatsuki had a similarly rocky start. It was supposed to it got to Venus for orbital insertion in 2010, but the main thruster that was supposed to turn on and slow it down so that it went into orbit failed to turn on. And so literally it just blasted right by Venus and kept on going. And so they were like, okay, what are we going to do now? They were able to use attitude control thrusters to 5 years later nudge it into a very different Venus orbit. And unfortunately, as a result of using energy on that, they had to turn off 2 of the infrared cameras in 2016 because they were afraid that they were going to fry their system. But Akatsuki has done some amazing stuff. I hope this is a movie. Yes, it's not. But this is a still frame from a movie of Venus's night side, as seen in infrared wavelengths. So you can kind of see, the wind blowing through, carrying the hot gases from the different layers of the atmosphere around the planet to the night side. And so and you can see clouds form and dissipate in the movie as well. So it's a pretty amazing movie, and that is still there today. In fact, as recently as 2017, scientists released puzzling data showing this large stationary wave in the upper atmosphere might be due to atmospheric flow over a mountain, similarly to how gravity waves are produced on Earth. So they also disproved some earlier studies in showing that wind speed at certain latitudes of the planet was different than previously thought. It actually had a sort of sidekick called Shinen Unitech 1. It was a student spacecraft CubeSat that was launched along with Akatsuki, and it was the first student-built spacecraft to pass through Earth's Van Allen belt, but it failed on its pass by Venus. So that's it. That's all that we've done so far. And you can tell after the Soviet Union fell, things slowed down quite a bit on the Venus front. So what is next? Well, India is planning to send the Shukrayan-1 probe in 2023. And so that should be very exciting. It joins the Chandrayaan-1 and 2 probes that went to the moon and the Mangalyaan-1 and 2 and MOM probes that went to Mars. So Venus is going to get a visit from India as well, which is super exciting. Russia actually has plans to go back to Venus, although the Russian space program is pretty woefully underfunded, as you may be aware. This spacecraft was originally supposed to launch in 2014. Now it's 2026 or later. This spacecraft is supposed to be done in conjunction with the ESA and NASA. And the D, that Venera D, stands for the Russian word Dozhoshila, which is long-lasting. So the idea is they want to have it last for a period of 10 hours or more on the surface. But 10 years have gone and come and gone since this was supposed to be there, and so it's long-lasting in a different way, unfortunately. And meanwhile, in Ohio, this is from the NASA Glenn Extreme Environment rig, the gear, at Glenn Research Center in Cleveland. And they were actually able to build circuitry that lasted in Venus surface conditions for 42 days. So they're working on making stuff that would work for a surface lander. They're also working on different concepts. We could have a drone that actually flies through the cloud tops. We could have a wind-powered land-sailing rover. And the rover would just go where the wind takes it and not have to worry about any of the stuff that we have to worry about with a powered and guided rover. And most amazingly, this is a concept for a zero electronics rover. So basically it would be a purely mechanical rover with no electronics whatsoever. And those discs that you see on top of the unit are designed to be observed from space and to report back what the surface are finding. The competition that NASA is running right now to get the general public to help them design an obstacle detector that works with a purely mechanical rover. So it's actually got serious cash prizes associated with it. This was brought to my attention by Parker Heelmantle. $15,000 for first place, $10,000 for second place, $5,000 for third place. And so basically what they want to be able to detect is that there's a rock in the path and be able to maneuver around it. So I think it's just the detection part, but check that out if you are looking for something to do in your spare time now that the world is shut down. So this is not it. If you've seen this presentation before, you know I talked about these, but there have been some new developments. The European Space Agency has a system that they are proposing called Envision. It is intended to perform high-resolution radar mapping, gravity mapping, and atmospheric studies. It would help scientists understand the relationships between the geological activity on the surface and the atmosphere of the planet, and it would help investigate why Venus and Earth have such different evolutionary paths. So this mission actually ties into a proposed NASA mission, which is called Veritas. So Veritas, in the tradition of NASA wacky program names, stands for Venus Emissivity, Radioscience, INSAR, Topography, and Spectroscopy. It's a proposed mission concept to map with high resolution the surface. It would combine surface topography and image data to provide knowledge of Venus's tectonic and impact history the timing and mechanisms of volcanic resurfacing, so basically lava flowing on the surface and changing the composition of the surface, and the processes going on in Venus's mantle, the boundary between the liquid layer and the solid and the crust layer, responsible for that. It was selected as one of 5 finalists for the Discovery program back in 2015, but it didn't win out then, unfortunately. And it was again proposed for the Discovery program in 2019. And on February 13th, 2020, just last month, it was selected for Phase A funding, which means that they are actually funding the project now, and a concept study report. So that will, it's still not funded. We're not funded to build it yet, but we're funded to investigate it and basically design it. And so it has survived to the second phase of the Discovery program. And finally, NASA may re-enter the atmosphere with the Da Vinci Plus, which stands for Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging. So I told you that the argon isotope ratios were weird on Venus compared to Earth. Well, this proposal, which lost out in the 2015 round of proposals for the Discovery program, was proposed again last July and actually shortlisted on February 13th. So Da Vinci is intended to study the chemical composition of Venus's atmosphere during its descent. It would travel through the Venus atmosphere, sampling the air, returning measurements down to the surface. And those measurements would help us understand, in conjunction with the other programs, the origin of Venus's atmosphere, how it evolved, why the argon ratios are weird, and why it's so different from Earth and Mars, which are a lot more similar. Da Vinci's measurements would reveal the history of water on Venus, the chemical processes at work in the unexplored lower atmosphere. And it would finally, for the first time in the history of humankind's exploration of Venus, take photographs from the air of the surface. And it has this weird terrain called tesserae, these ridges on the ground. And so this would be the first mission to ever hopefully successfully take a picture of that and not just image it from orbit. So I hope those new programs are exciting. I don't know apparently how to turn off this laser pointer, but here's a video, a very low resolution of Venus spinning, and that's my. So if you have any questions, please feel free to put them on the channel or in the chat, and I'll do my best. Or unmute yourself and just ask.
All right, Jonathan, I got a couple for you.
Uh-oh.
They're not directly related to like Venus missions, but I'm passing the buck to you. I got this question asked at a planetarium show, and I kind of dismissed it out of hand. I want your take on it. A guy suggested that Venus had stolen Mercury's atmosphere.
So there is, so this is outside my realm of expertise, which is a very small realm to start with. But there is a school of thought that is not completely composed of conspiracy theorists that says that the weirdness of Venus and Mercury are related, because Mercury is a planet that is mostly metal. It looks like the other rocky planets, except without the outer 2/3 of the planet. And Venus is a planet that is rotating exceptionally slowly backwards. And oddly enough, Venus and Mercury have certain orbital resonances, and Venus and Earth also have weird orbital resonances. So basically, every time we line up with Venus, the same side of Venus is facing the Earth. So there's no tidal locking per se, but we always see the same side of Venus from Earth, which is kind of funny. Um, so I would say, it's I wouldn't say it's the scientific mainstream, but there are real scientists who are exploring those possibilities. I'm sorry, that's kind of a cop-out, but that is the truth.
Yeah,
Cool.
no, I kind of suggested the same thing. That sounds kind of unlikely, but he was under the impression that the sun, the solar wind, pushed Mercury's atmosphere back and then was captured by Venus, which I found much less likely.
Oh boy.
Then my other just mean-spirited question is why study Venus when we can just turn the Earth into Venus and study the Earth?
Okay, let's not.
That's such a sad question. I think, I'm gonna try to just keep this up in the background. Our argon ratios are totally different, so we can't really turn it into Venus, even if we. So there.
That's a nice, safe answer. Any more questions?
Let's see if there's anything on the. See if there's anything on the YouTube channel. All right. Anybody else? Anybody
All
else?
right.
I will make a comment. Can you hear me good?
Yes,
I can.
we can hear you, Jeff.
So those low wind speeds, they sound low, but with the densities of the Venusian atmosphere, those would be pretty sizable winds.
That's true. In terms of the actual molecules of sulfuric acid gas passing over your body, definitely a stiff breeze and an unpleasant.
Yeah, I mean a meter per second at 100 atmospheres, you're going to be knowing about that.
Yeah. So I have no plans whatsoever to experience that. So I got a question from Diane Rosato on the YouTube channel. What first got me interested in Venus? I have to say a big part of it. Well, part of it was I started getting into astronomy actively through Mike Narlock of Cranbrook Institute of Science and through Marty Coons of the Warren Astronomical Society back in 2000 and kind of starting in 2001 and really actively in 2004. But I was in college and really busy with college, and I completely missed the Venus transit. And when I found out that this twice in a lifetime thing was happening in 2012, I had this incredible level of pain that I had missed this thing the last time it happened and determination to make sure that I wasn't going to miss it again. And I started just reading books about it, and I read the James Dean of his day, Jeremiah Horrocks, a amazing astronomer from the early 17th century who died at 21 years old after possibly figuring out Newton's laws 50 years before Newton did. He wasn't quite as brilliant in quite as many ways as Newton, but again, he only lived to 21. So imagine what he could have done if he hadn't died so tragically young. But he was such a mathematical whiz kid that he got Johannes Kepler's tables of planetary motion, figured out that Kepler was right and everyone else that they were teaching at his actual university was wrong, and then figured out that Kepler had made some math mistakes and corrected them and found out that there was actually a second Venus transit when Kepler thought there would only be one. And so he and his friend William Crabtree and his brother were the only three people in the entire world who saw the Venus transit of 1619, which is pretty cool. So
16. What?
I don't know. It's been a while since I gave that presentation.
Okay.
Wasn't
No,
it 1619?
No.
1621?
It was sometime during the Cromwell era, so it was like 1640s, I think. Middle of the century.
Okay,
Because
well,
the Civil War was didn't Crabtree die in the Civil War?
yeah, Crabtree died. No, Crabtree didn't die in the Civil War. Their other William Gascoigne died in the Civil War.
Gascoigne. Okay, yeah, but it was mid 17th century.
Okay, see,
Yeah.
this is my English historical military history is really lacking. So, I think you're right. I think it was 1641. Maybe
I think it was
the second
41 and 48 were the two, and one of them was seen by nobody, and one was by those
by
three
the
guys.
three. Yep.
Yeah. Cool.
So that's how I got started on it, and also I will admit I'm just a big fan of underdogs in general, and with everybody and their sister and their sister's boyfriend's mother's brother's pen pal sending a Mars probe over to Mars, I really feel it's unfair that nobody will send probe to Venus because I want to see more Venus stuff. So that's the other reason.
All right. Well, thank you, Jonathan. It's 9:00, which is the time we said we would wrap up. However, feel free to linger in the Discord. Feel free to keep on hanging out. And if we have any additional questions, Jonathan can see you. So,
All right. Thanks so much for being a part of this first all virtual meeting of the Warren Astronomical Society. I'm hoping that we don't have too many of these and that we get back to meeting in person before too long. But it's a pretty fun thing to do, and we may try to do some live streaming of presentations even after we return to normal.
yep. Thank you very much, everybody, for joining us, whether by YouTube or Discord.
Thanks, guys.
And we keep in touch. We will notify you of our next event, which presumably will be a virtual open house hosted by the Northern Cross Observatory. Since we won't be doing gastronomy tonight, I hope you have a good evening wherever you are. Thank you.
Great job, Jonathan.
So,
And everyone.
just as one final thing, Ken Lord Googled it, and it's 1639 was when Crabtree and Horrocks observed the transit of Venus.
Okay, so it's 31 and 39. Okay.
Yeah, and William Gascoigne tried to observe it, but he wasn't. It was cloudy where he was. But he invented the filar micrometer, and then he got killed in the Battle of Hastings. So, or one of the battles of the
one of the battles of Hastings. Yeah.
Yeah, not the old Battle of Hastings.
not the William the Conqueror one.
Yeah.
You'd have to invent a time machine for that.
Who knows?
All right.
Really. All right, everybody. Thank you for joining.
Thank you. Great job. Thanks.
Thank you, folks. Good job.
Thank you, Doug.
Yeah,
Thank you,
you're welcome.
Doug.
So I'm going to disconnect the YouTube, close it down. Thank you for joining us for our first virtual meeting.